Okay, cleaning. First, I'm gonna submerge these metal parts in vinegar, and that should eat off most of the corrosion. But first we have to remove some of these plastic bits and this little PCB with the LED on here as well, as well as any screws that are in here, because the screws are pretty much okay. So I just want to remove the rust from the metal plate. And as I said, all these screws are the same size, and it says in the manual which ones go where, so I'm not really taking track of which go where. It should be like that, right? So there's a little plastic peg, and you just have to pinch those two lips in, and you can pull the PCB off. So like that. And this is just double-sided adhesive stuck on there. Yeah, I don't think I'll remove that. Maybe I will remove this. Also, this metal plate, which is very thin metal, it's not really that corroded, so I'll just give this a light scrub with some soapy water and call it good. So to submerge this in vinegar, I have a tray here, or a plastic box thing. And these are perfect for these kind of tasks, also for retrobriting stuff, as long as it's not too big. These come from a well-known Scandinavian furniture store. Just flip that around. Is that flat? No, that's not flat at all. Okay, so, and this is just normal white cleaning vinegar. And if this is not aggressive enough, I will switch to white vinegar, which you use in the kitchen, because it's a little bit more aggressive than this. So just pour it in. Yeah, just use all of it. And you'll see it starts to fizz right here. Maybe if I go a bit closer. It starts to fizz, and that's just a chemical reaction between the acid. Vinegar is acidic, so it's a chemical reaction between the acid and the corrosion, and the stuff causing the corrosion, and it should neutralize it and remove a lot of the corrosion as well. So I'll just let this sit for a minute, or for a couple of minutes, and check back on it later. And I think I'll just use a toothbrush to kind of scrub at it and try and remove as much corrosion as possible. Now we already cleaned the main board, so we don't have to do anything about that. This modem thing, I guess I'll attack first. just clean out the connector to see, yeah, if it cleans out properly. And just turn on a little bit of light so we can see what we're doing. Yeah, I need to dry this off. Good enough for me. And I'll just use some 99% IPA. Okay, and that's clean as well. Connectors all looking nice, shiny, golden again. And then we have this one. Yeah. I'll probably just start by putting a little bit of vinegar on the oxidized spots and see how it goes from there. I have to remember to keep this one. I'll just leave that to dry right there for a minute, and let's go check on the metal parts to see how the vinegar is doing, or actually how the metal parts are doing and how the vinegar is affecting them. And just brush a bit at it. And we'll just leave this soak a little bit more. Okay, I started working on the power supply PCB, and first I connected the DC in LED to it and connected the power supply, the external power brick. This is a different one. This has a higher amperage on it, so it actually just powered through any shorts that were in here, and yeah, probably not the recommended way to do it, but then you can kind of feel which components heat up a lot and check those out. And as you can see, I removed two transistors, or actually MOSFETs, from here and a capacitor from here. And I will be doing most of this removing of components off camera because it's really a pain in the ass to remove them. So I removed this cap, and I removed these two MOSFETs. And the reason I removed the MOSFETs is, I don't know if I can get this to show up on camera, but let me try. As you can see, the one here has a crack in it. And when I measured it in circuit, it showed that it just had continuity across all 3 pins. And well, that's not really how MOSFETs work. So I took them out and I put them into my cheap Chinese component tester. And I'll first take this is the broken one, so the one with a crack in it. And I put them in the component tester, and it just shows up as resistor. So this one is definitely broken. And if we now test the other one, it shows up as an N-channel MOSFET. So this one is probably still good. At least it still functions like a MOSFET. And next, I took out the capacitor because the capacitor is connected to these MOSFETs. And by the way, this is all part of the battery charging circuit. So it runs to these 2 wires, which run over here, which run to these 2 connectors, which go to the batteries. So this is part of the charging circuit. So I just removed them to see if, well, that would fix the power supply, because it was just cycling on and off, and there was a huge voltage drop on the DC in barrel jack, and it didn't even do anything. So it's probably because one of those MOSFETs was shorted out. They both became very hot as well. So it's just fault finding, just trying to see which components are broken, try to measure what it should be, and replacing it. So I removed the capacitor because I thought it might be faulty, and it shows some evidence of leaking. And so as you can see, there's some electrolyte and there's some gunk on the leg. So this one is definitely leaked, but is it actually a problem? Is it out of spec? And that's the beauty of these cheap component testers. And of course it's questionable how reliable they are, but it's good enough to give an indication. If we just connect the capacitor and alright. Yeah, the connections are not always as good, so just test it again. Come on. Try this again. So it shows up as a 1200 something microfarad capacitor with an ESR of 0.13 ohms. Now 0.13 is, these are pretty high quality, high precision capacitors, so it's more than it should be, but it's nowhere near actually being really broken, being really bad. Unfortunately, I don't know at what frequency this thing tests, so it could be that it just fails at very high frequency, because basically all this is a switching power supply, and it's just a couple of oscillators with some boost buck converters, and that generates all the voltages. So this is a microprocessor, and this is a microprocessor, and this thing over here is basically an inverter. It's some MOSFETs, and that one is the same. And these are just some inverters or some logic gates, and I don't really know what that is because I don't get anything at all when I Google the part number. And the rest of this is just resistors, diodes, some inductors, some capacitors. So it's just a basic boost buck converter. And all of this operates at pretty high switching frequencies, and it generates the required voltages. It steps it up or steps it down from the 12 volts coming in from the DC input jack. So yeah, it's a pain to remove all of them because everything is oxidized, and it's really hard to unsolder, desolder oxidized stuff. I will also have to replace the switch because I tested it and it's completely dead. So yeah, more tracing, testing, debugging, and I'll probably cut it up into some clips and make a time lapse or something, I don't know. But yeah, this is going to be some time to get this fixed. So I removed all the capacitors and a couple of other components. Why? Well, I removed one capacitor, that one, and I measured it and it looked okay, but there was some electrolyte underneath it. However, when I removed the other ones, I saw a whole lot more electrolyte under there. Also, I removed the broken, or I left the broken transistor out. I also removed these two, which are diode pairs, and they both seem to be fine. I measured them and they both have the correct diode drop. And I removed this NEC. This is a 2SK814, and that is a N-channel MOSFET, and that one seems to be broken as well. And when I removed the last capacitor, I saw a whole lot of corrosion damage. There was a lot visible on the bottom side of the PCB as well, but the top, I mean, it's just all green and gunky and yeah, bad. You can actually see underneath these and this one here a bit, and they are also a different brand, different kind, different color, etc. From the other ones, and they seem to be fine. It looks like they're just output capacitance. But the ones I removed, and those are over here, they all have either corrosion or some signs of leakage on them. So even though they measure fine and they look to be okay, yeah, I'm still just gonna replace them all. And I will have to find the replacements for these two as well. And that will probably have to come from eBay from somewhere, because they don't make these anymore, obviously. So next up is cleaning the PCB up a bit and trying to open up all the holes for all the through-hole components I removed, and check from there. And a lot of parts are gone. I actually removed all the capacitors first because, well, there were quite a few that were leaky or not great. And all the electrolyte running underneath all the components, I couldn't really tell which ones were good, so I took them all out. And as we can, I don't know if you can spot it very well, but there's a trace right there. That one here, that's broken, and that's actually the only trace that's broken. All the other ones seem to be just fine. Also on the bottom side, it's messy, but I tested everything, and I actually drew out a lot of schematics of how this thing is, how it's all connected up, and there's another one right here, and this is actually a lot of work, and I used the pinouts of the large interconnect, the ribbon stuff, this one. The pinouts of these two are known and they are in the service manual, so I used those to test which capacitors and which pins went where, and I actually found that the negative terminal of C4 is the negative 9 volts, C3 and C64 are connected together, and those provide the 12 volts. C1 and C2 are connected together, those provide the 5 volts, and HDHV is hard drive high voltage, hard drive low voltage, and hard drive motor voltage. And RAM voltage, LCD voltage, and I really don't know what that one is, but at least I have some points to measure and I know what they should be, and I managed to trace it out and draw a pretty significant portion of the circuit diagram. And I have also put this in Eagle, and I will link that file down below. But after taking all the components out and testing them, we got a whole heap of dead parts. I also killed this one, and I'll have to find a solution for that. I broke the pins off. Yeah, not great. And this capacitor here I have a replacement for, but yeah, I'll just see what I'm going to do about that, and I don't know what this thing is doing even looking at the schematics. So as I said, I destroyed this tiny little diode. It's number 9 on the PCB. I broke off 2 of the pins. Yeah, it's just a stupid mistake, but the pins are still there. You can still see them, but they're just broke off flush with the packaging. So I'm going to try to fix it. I think I know what kind of diode it is. It's just a regular Schottky type diode, and it's just connected on pins 1 and 3, so not really that much happening. And I can probably replace it, but it would be nice if I could just use the original one. And I have tried in the past on small ICs to file down a bit of the package, of the plastic packaging, to reveal the pins, so you have something to solder to. But this is just too tiny. Your hands aren't steady enough to file straight between the pins. I have tried that, but yeah, it doesn't really work. But I have had success in the past using this. So, and I can't get this on camera, it's just impossible. It's too fiddly, too tiny, and I do have some head magnification to help me. But yeah, I'll try to fix that tiny component with this huge Dremel, and just to reveal enough of the packaging, or to reveal enough of the pin to solder some of these tiny barge wires to it and reconnect it to the PCB. I'll probably also glue it down, just solder it on the one pin that's left and then glue it down on the PCB, just to give it some stability before trying to solder the barge wires to it. So yeah, let's give that a try and see if it doesn't just fly off. So that really didn't take all that long. It's very small and it's just soft. So the Dremel actually cut it pretty decently and pretty fast, and I'd call this a success. And there we have it. So it's back on. It has a little bit of super glue just to keep it in place. It's connected through 2 tiny barge wires, which I just used a larger piece, which was already tinned at the end, and just touched it on there and then cut the excess off. So now it's back on there, and let's see if this repair worked. Okay, measurements. Turn that one on. Check to see we have 12 volts over here. Yeah, okay, 12.13, that's great. And now this LED, this is the DC in LED, and that one won't come on because it's controlled by one of the, I believe by this microcontroller. So we'll just plug it in. Well, nothing has blown up yet, so that's a good sign. Let me just try to get some light in here and avoid some glare on the, actually, Can I just... Yeah, that's better, isn't it? Okay. So I should have 12 volts. Yeah, I should have 12 volts right there. And I do. Okay. So that's a good sign. Let's solder in the fuse. And well, we'll have to see if anything else blows up, or if anything blows up actually. Yeah, so my camera cut out on me. I don't know what you have seen and what you haven't, but I soldered in the fuse, and let's plug the power in, hope nothing blows up, and try to see if we can do some measurements on these two ICs and probably on some capacitors as well, just to check what voltages we get without turning the power supply on. And let's keep our eye on the DC in LED, and here goes nothing. Yeah. So the plug is still a bit screwed, but we got a solid DC in LED. And let's see if we can do some measurements. Okay, new day, new developments. Well, as pretty much, I guess all of you expected, it didn't really work. I couldn't find anything wrong other than the missing Q5 transistor, and of course that one that's still blown, and I still don't know what it is. So there's that. What I have done is tested some stuff and verified that I do indeed have 5 volts for IC12 here, the 4-bit microcontroller, so that works. I have 12 volts on all the 12 volt rail capacitors and also on the connector here, and I also have 5 volts on these pins here, which I guess is 5 volts standby voltage for the SRAM, and the connector here for the sub battery, which is the backup battery for the SRAM, that also has 12 volts on it to charge it. So yeah, it looks pretty good, but it doesn't do anything, as you have seen. I have done some measurements, and it seems that there is no clock signal, and it should be coming from X2 over here, which is a 3-pin ceramic oscillator, and there's just no clock signal on this chip. It does have 2 clock inputs, a fast clock and a slow clock, which it's one of these over here, and there's just no clock signal. So that could mean a couple of things actually. It could mean that I really need Q5, and it could also mean that the ceramic oscillator is dead. Doesn't seem very likely, but yeah, who knows. And it could also be that the microcontroller is dead, that it's just not executing. Or it could be that it's switched to low power mode, and in low power mode it uses the internal oscillator, at least as far as I could tell from the datasheet. But it's a pretty darn old datasheet, and it's kind of hard to read actually. So yeah, there's that. But look what came in the mail. A brand new 2SJ132 P-channel power MOSFET. Yeah, there it is. So it's actually 2SJ132, but this is a brand new transistor. Let me warm up the soldering station and get that transistor in and see if we get some more life out of this.